Hi everyone, my name is Ahmed Masry, a PhD student at York University, and today I will be presenting our work, which is ColFlor towards BERT-Size vision language document retrieval models. So this work has been accepted at the third Muslims in ML workshop, which is co-located with NeurIPS' 2024. And this work has been done at York University in Canada. So traditional document retrieval systems often rely on OCR. So documents like PDFs, traditional approaches have been using OCR methods to extract text from them. And this process is usually error-prone and resource-intensive. So recently there has been some progress in OCR-free methods, like document retrieval methods, which utilize large vision language models, such as ColPali, which is based on the Pali-Gamma model. However, the problem with these models is they have billions of parameters. For example, ColPali has 3 billion parameters, which makes them like very computationally expensive, especially for large scale applications. So there is a high need for cost-effective OCR-free document retrieval models for those large scale applications and also for resource-constrained environments. So in this paper, we introduce ColFlor, which is an efficient document retrieval model with only 170 million parameters. And through our evaluation, we show that ColFlor has comparable performance to much larger models, such as ColPali on the text-rich English documents, despite being like 17 times smaller. And we also show that our model is significantly faster in encoding images and queries. So let's dive into our model architecture and our system design. So for our model architecture, we utilize the Florence 2 architecture. So for a vision encoder, we use DAVIT, and for the text encoder, we use the BART text encoder, and we fine-tune our model on the Vidore dataset. So in our retrieval system, we have two-stage approach, indexing and querying. So during indexing, basically giving a document image, a document page, we give it to our David vision encoder, and then we pass the output to our BART text encoder to produce some visual embeddings. And then during the querying phase, giving a user query, we encode it using BART text encoder to produce some text embeddings. And then we compare the embeddings of the query with the embeddings of the document image to measure the similarity. So how do we compare those embeddings? We use an operation called maxsim, which is designed for fine-grained similarity. Basically, each embedding from the query is compared with each embedding from the image embeddings. And the maximum, the two embeddings with the maximum similarity are selected, and then we compute the similarity between them. And finally, we sum the similarities of all these different vectors together to produce the final similarity score. So this maxim operation is useful for fine-grained similarity. So after designing our model and training it, we decided to evaluate it on the Vidore benchmark, which has diverse set of documents. So as you can see here, it has like English documents, it has like figures, it has multilingual documents, for example, French. So on the English documents, we have different datasets or subsets, such as DocVQA, TADQA, and so on. And we notice that our model performance, ColFlor, is very comparable to ColPali. The difference is almost 1.8%. Even though our model is significantly smaller. On the figures category, we realized that our model is underperforming. There is a huge gap between it and ColPali, and this is mainly because of our training doesn't focus on figures. And finally, on French documents, we realize our model performance is very poor, and this is mainly because our model was only designed for the English language, and it's not a multilingual model. In addition, we also measured the efficiency of our approach, and we compared it against ColPali. So we ran our model ColFlor and ColPali like on T4 GPUs, and we basically measured the running times over 1,000 documents, and we averaged all of them. So we realized that in image encoding, our model is 5.25 times faster than ColPali, which is the previous state of the art in image encoding. And in query encoding, it's 9.8 times faster. So this makes our model very suitable for resource constrained environment, or for applications which are time sensitive. They require like immediate responses. So for future work, we plan to enhance the performance of our model. In particular, we will continue the pre-training of the backbone model, which is Florence 2, on figure datasets and charts and infographics. So this will hopefully improve the performance on figure-heavy tasks. In addition, we will also include multilingual support. So we will develop a multilingual variant to basically support many more languages, and this will broaden the applications of our model in real-world real-world scenarios. So in this work, we introduced ColFlor, which bridges the gap between like performance and efficiency in OCR-free document retrieval systems. And this model is obviously a viable alternative for resource-constrained applications, which in environments which cannot really run those multi-billion parameters large vision language models. And finally, our model democratizes access to multimodal document retrieval systems. So our model is first of its kind. It's the smallest multimodal document retrieval models right now. And this basically allows researchers from underrepresented groups or underdeveloped countries with limited computing resources to be able to like experiment with those multimodal document retrieval systems and improve them in the future. So yeah, that's pretty much it. Thank you so much for listening. And if you are interested, feel free to check out our demo, our model weights, or our training codes. Thank you.